Proportions. Why? Why do we need to learn about proportions? What purpose do they serve in our day-to-day life? Well, actually, they serve a rather large purpose. First of all, if you've never worked, just imagine that you're working for somebody, and I would hope that most of you have worked in one capacity or another. And if you get an hourly rate, if you get paid per hour, that's a proportion. So it matters. If you want to get paid in your life, then proportions matter. If you want to drive a car and you want to know how the speed of the car is related to how long it takes to get to your destination, then yes, then it matters. Even if you don't drive yourself, if you take a bus, you take a train, you take an airplane, the speed matters and directly affects the time it takes to get someplace. So proportions overall, think about relationships. The proportions are relationships between two or more entities. Welcome to our masterclass on proportions. As we see on Henry's sheet, we talk about directly proportional relationships, and then after that we talk about inversely proportional relationships. But when you think about proportions, you think of a relationship between two or more entities. If two entities are proportional, that means if one goes up, the other one goes up at the same rate. If they're inversely proportional, it means if one goes up, the other one goes down at the same rate. So looking at the first example of a directly proportional relationship, and remember, when you look at proportions, look at the most basic ways of rewriting the relationship. So the first example that you have on our smart worksheet, if a car gets driven, for every 7 miles driven, the odometer only reads 6 miles, so it's a defective odometer. So how do we set this up? We have driven and we have registered. For every 7 miles driven, we only register 6 miles. So if the question here now asks, if the odometer registers 54 miles, and we want to know how many miles was it driven. And we're using some very simple numbers here to really illustrate this concept. So if you look at it, from 6 to 54, and by the way, proportions are always about multiplication and division, never ever addition and subtraction. So how do we get from 6 to 54? We need to multiply by 9. Now, if you're not up to speed with your multiplication table, two things. One, get up to speed with it. Yes, we can use calculators for everything. Yes, we have a cell phone with us all the time, and we can use the calculator on there for everything. But that doesn't make you think, and you need to keep working those muscles in your brain. So keep working those muscles and think. Now, if this is hard to do, then do 54 divided by 6, and that gives you the factor of multiplication. So when we have a directly proportional relationship, that means whatever we do to one side, we do to the other side. So we multiply by 9, 7 times 9, multiplication table, 63, and that's it. So that's a very simple, directly proportional relationship. Got it? All right, let's look at example 2. In example 2, we're making it a little bit more tricky. The numbers are less intuitive maybe in the beginning to work with. So let's see how we're gonna deal with that. So here we're starting with 100 tea bags, and the 100 tea bags, they weigh together a total of 8 ounces. The second part is that we want to know just how much 3 of these bags weigh. So now you cannot divide 100 by 3 evenly. So we're going to use a little trick here. So what we're going to do, we're going to say, well, how do we get from 100 to 1? And 1 is our filler. We can always go down to 1. Anything can be divided and you get 1. How do I get from 100 to 1? Very simple. I simply divide by the number itself. So to get from 100 to 1, I divide by 100. And how do I get from 1 to 3? I multiply by 3. So I need to do 2 steps. I divide by 100, I multiply by 3, and then I'm getting to my 3 bags. Still not very hard, right? This is an intuitive way to solve proportions. Now, how can I do this in one step over here? Well, this is where you're really going to engage those brain cells. Well, dividing by 100 and multiplying by 3, we can do this in one step when we use a fraction. And that would look like divide by 100, so that's the denominator, multiply by 3, so we can do this in one step, divide by 100, multiply by 3. So what we can do now, instead of dividing 8 by 100 first, let's multiply by 3. 8 times 3, again, use your multiplication table, 24, and 24 divided by 100. So either we can just say this is 24 divided by 100, or we can use a decimal and say it's 0.24. That's it. Not that hard when you're really going down to how much does one bag cost, or in this case, how much does one bag weigh. Ready to go on to example 3? Let's do it. So now let's talk about a particular proportion where we need to deal with integers. Cats to dogs. We have a ratio of cats to dogs at a shelter of 3 to 5. That means, first of all, for every 3 cats at the shelter, there are going to be 5 dogs. That also means out of 8 animals at the shelter, so that will be the total, out of 8 animals total, 3 are cats and 5 are dogs. And another thing you can directly derive from that is the difference between cats and dogs is 2 when there are only 3 cats and 5 dogs. So this is what we can derive from that. It's also good to wrap your head around the interpretation. Now, is it possible to only have 1 cat at the shelter? No, absolutely not. Because if you have 1 cat, you need to divide both of those by 3, and then you have 5/3 of a dog. I don't think my dog would appreciate that. No, absolutely not. So we need to keep integers here, we need to keep whole numbers here. And that's why we can do more with that kind of ratio. So the question now is, if there are 21 cats at the shelter, how many dogs are there? Now we go back to what we did the first time around, and we went from 3 to 21, pretty simple, multiply by 7. That means we're going to do the same thing over here, 5 times 7, and if you came up with 35, you're absolutely on the right track. What if the question instead asked, how many animals are at the shelter? Well, instead of multiplying the dogs by 7, we could have just multiplied the total number by 7. 8 times 7, 56 last time I checked. What if it just asks us, instead of how many dogs there are or how many animals total, what if it asks us instead, what's the difference between cats and dogs if there are 21 cats? Then we could have done directly to the difference and said 2 times 7, 14. See how everything is in sync? And if you do that, you see 21 plus 35 indeed is 56. And the difference between 35 and 21 indeed is 14. So there's a lot you can derive from this one piece of information that is given. And that is really cool about that. What else do you know for sure if your answer has to be an integer? Well, you know, for example, that the number of cats must be a multiple of 3. The lowest ratio will always tell you that. You know that the multiple of dogs must be, the number of dogs must be a multiple of 5. You also know that the number of total animals must be a multiple of 8. It's right here. And you also know that the difference between the cats and dogs must be an even number because it has to be a multiple of 2. So again, there's a lot of information that you can derive from this one piece that is given at the very beginning, that the ratio of cats to dogs is 3 to 5. Now, let's use this information to work on more than one relationship. All right, so now we have 2 different relationships that we need to combine into one overarching relationship. we're given that the relationship between x to y, the proportion is 3 to 5. So for every 3 x's, you get 5 y's. Then we have a relationship between y and z. For every 25 y's, you get 7 z's. So now the question is, what's the relationship between x and z? Now, we cannot just continue here because we have a different relationship here. We have different numbers. So what we do, we use this information, we add z to the side here, but we need to go on a separate row here and set this up separately. So this is how we combine everything into one place. So now we need to know, how do we get from 5 to 25? Clearly, we're multiplying by 5. So we do the same thing to the 3. We multiply by 5 and we get 15. So when we have 7 z's, we need to have 15 x's. So that's the relationship we're looking for. So this is how we're combining, and we can do that with 3, 4, we can do that with however many you want. And that's really cool because you can really see how you get from one relationship to another. Now remember, when we have an inverse relationship, we are looking at a relationship where if one entity goes up, the other one goes in a different direction by the same ratio, not the same amount, but the same ratio. So we're told that we're driving for 30 minutes at a certain speed. Now we're not given a speed. That means we can just make it up. We can choose our own starting value and a simple number that comes to mind for me, but you can choose anything you want that makes sense to you. And we're driving for 30 minutes at a speed of 30 miles per hour. We're just gonna use the same number here, which is just fine. And then we're asked what happens when we're doubling that speed. So we clearly need to multiply by 2 to double, and we're coming up with a speed of 60 miles per hour. So what's gonna happen on the other side? If you're doubling the speed, is it gonna take you longer or less time to get there? And you're absolutely right if you said less time. So what we're doing here is exactly the opposite. Here we'll multiply by 2, but here we need to divide by 2, or we could also have multiplied by 1/2. That also works. We can multiply by the inverse. And that means we're gonna cut 30 by 2 and we come up with 15 minutes. And that's our answer here. So that's a very simple way to illustrate an inverse relationship. In example 2, we have an inverse relationship between x and y. And we're told that when x is 5, then y is equal to 15. Now the question is, what happens to y when x increases to 25? So again, I start by just looking what happens on the x side. From 5 to 25, I multiply by 5. Yes. Okay. So what am I going to do to the other side if it's an inverse relationship? And if you're telling me that I'm dividing by 5, or I could multiply by 1/5, I can write that out, or multiply by 1/5, same thing. Then from 15 divided by 5, I end up with 3. So I start with 5 to 15. Now when I change these numbers, I go from 5 to 25, but the 15 gets reduced to 3. Again, that's a very simple, straightforward, inverse relationship. All right, in example 3, we have 3 different units. We have a relationship that is given between n and p squared in this case. Not p, but p squared. And they're inversely proportional. When p is equal to 1/2, so we start with p and we put that in between. When p is equal to 1/2, then we know that n is equal to 8. So first step, we stay in this row here. Well, if p is 1/2, then what is p squared? We do need to figure out p squared same way we did on the other page with the proportional relationships. Well, what is 1/2 squared? It is 1/4. 1/2 of 1/2 is 1/4. When n is decreased to 1/8, we want to know the value of P. So that's what we're looking for. So in this case, we're having a reduction. Now, what do we need to divide by to get from 8 to 1/8? And if that kind of stumps you, do it in 2 steps. How do you get from 8 to 1? You divide by 8, right? 8 divided by 8 is 1. How do you get from 1 to 1/8? You divide by 8 again. And if you're dividing by 8 and divide by 8 again, you're simply dividing by 64. So divide by 64. That's how you get from 8 to 1/8. And what am I going to do on the other side? The opposite. So I am multiplying that by 64. That's what I need to do to b squared. And again, you can break that down. 64 is the same as 4 times 16. 4 times 1/4 is 1, times 16 is 16. So 64 times 1/4 is the same as 16. But now I'm not done yet, because I need to now go from 16 to p, to the square root of that. So the square root of 16 can be positive or negative. And if you pay attention to the wording in this problem, it says what is one possible solution. That's because it can be positive or negative 4. So yeah, that was a bit more complex, wasn't it? But very doable if you do it one step at a time. Look at one term at a time, another math strategy that we highly recommend, and do it also one step at a time. Always ask smart questions. What does the given information mean? What do I know about it? And focus on what we do know rather than get overwhelmed with all the data all at once. Break it down, break it down, break it down. All right, now your job is to go and apply this in all the proportions problems that you can get your hands on. Good luck with that, and thank you so much for joining us today.